Do you want to build a snowman or learn some more about triangles? Well, we're going to do the second thing. We are going to continue our lesson on angle relationships in triangles. So our learning target and success criteria is staying the same as last time here in section 22.2. But we're going to go into some more examples and how we can apply it a little bit more today. So we're still going to make sure we know and use different properties in angles to find missing things. And those success criteria, remember, 3 angles in a triangle add up to 180 degrees, no matter the triangle, as long as it's a triangle. Second success criteria, the exterior angle of a triangle is equal to the sum of the interior angles. I don't know if that comes up in today's lesson. I don't think it does, but it adds up to the 2 non-adjacent interior angles, so the ones that are not touching it. And then finally, another thing that we're going to use is know that if 2 angles in one triangle are congruent to 2 in another triangle, then the third angle in each are also congruent. All right, so let's go on in your notes book to page 200. And if you could follow along, we're going to start right up in number 2 here. It says, let's explore triangles in relationship to angles formed by intersecting lines. So let's look at number 2. Explain how you know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. So that's this angle, and this angle. So think back to last lesson. One of those things with angles, if there's angles that form a line, what is it called? It's called a linear pair. In this case, it would be a linear triple because there's 3 of them. But anytime you have all angles that make a line, lines are 180 degrees. So we can say they form a line. We'll say a straight line. Oops. Form a straight line, which is 180 degrees. Lines M and N are parallel. What's the relationship that tells you that each of these statements are true? So let's say that these 2 lines going across, and I'll highlight them in blue, are parallel. So that goes back to last lesson as well. So we know a lot of stuff with parallel lines and transversals. So how do we know that angle 1 and angle 4 are congruent? Well, let's look at what type of angles those are. Those are on the interior of the parallel sides, and they're on alternate sides of the transversal. So those are alternate interior angles. How about number 4? Why is 3 and 5? Why are those congruent? 3 and 5. Well, guess what? I'll use a different color just so we can tell the difference. Those are also alternate interior angles. Same idea. And we know alternate interior angles, when formed by 2 parallel lines and a transversal, are congruent. All right, let's move on. Number 5, explain how you can use congruent angles from numbers 3 and 4 with the equation in problem 2 to show the sum of the measures of the angles inside of the triangle is 180 degrees. So this is something that's kind of like a proof. So you'll learn about proofs in geometry, but we're actually using what we know to prove something. So let's look at what we have here. We have originally that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180, because that was a straight line. Then we said that, well, the measure of angle 1 in number 3 here, the measure of angle 1 is equal to the measure of angle 4, which means they're the same. That means they can replace each other. They can be substituted for each other. So let's take this and put it in for there. And then in the second one, it says 3 is congruent to 5, or the measures are equal to each other. So we can put in 5 in place of 3. Meaning, if I were to write this out then new, I would have, let's see, instead of 1, I'm saying 4. So the measure of angle 4 plus the measure of angle 2 plus the measure of angle, what am I replacing 3 with? 5 is 180 degrees. And look, 2, 4, and 5 are the 3 angles in our triangle. So that's a way to prove, you just proved something. We just proved that the 3 angles in a triangle add up to 180 degrees. So I'm going to write that out. This proves that triangle angles sum to 180 degrees. All right? So we're just taking some of the things that we learned in the last lessons and combining them to show that really angles in a triangle do add up to 180 degrees. Let's go to the bottom of page 200 here. It's number 6. Different example, different triangles here. It says use the facts about triangle angle sums, so we know they add up to 180 degrees on the inside, and similar triangles to solve this problem. Triangle PQR and triangle STU are similar triangles. So real quick recap. If you guys remember similar shapes, when we talked about dilations, they're shapes that are the same shape but have different size, meaning a bigger or smaller version. But interesting thing is that the corresponding angles are always congruent to each other. So the angle measures don't change, but the size of the lengths of the sides do. So if these are similar triangles, the angles don't change, but the lengths of the sides will. So what we're trying to do here is it says triangle PQ, they're similar triangles. In triangle PQR, the measure angle QPR, so it's labeled here QPR, right here is 60 degrees. And the measure, or an angle PQR is a right angle. So those are both labeled in there for you. All right. Now, we want to explain how you can solve for x. So we want to find this. But we don't have anything in this whole triangle. So what we need to do is use what we know about similar triangles. If they're similar, the angles that correspond are also congruent. So that means this one, which is already labeled, is a 90-degree angle. And then you got to find which one matches up with the 60. So this is 90 degrees. I'm going to write that in there. So which one matches up with P? Now there's two different ways you can check that. First of all, I think you can tell it's kind of obvious. This is a different angle than this. They look different. Same thing within this triangle. S and U, I guess, look different. So you could probably tell that this one is a 60-degree angle. But you can also look at our statement. It says triangle PQR and triangle STU are similar. So if we know P is the 60-degree angle, the one that's in front for STU should also be the 60-degree angle, and that would be S. So now, explain how we can solve for X. Really, I could think of multiple ways to do it, more than one way. You could use what we learned last time, that the exterior angle, this is an exterior angle, is equal to the sum of the other two interior, the ones that are not adjacent to it. So that means that X should be equal to 60 plus 90, which is 150 degrees. So X is 150 degrees. That's one way to do it. A second way you could do it is if you know inside of a triangle we have 60 and we have 90, that adds up to 150. You can do 180 minus that 150 to find the third angle. You get 30. So that means that this angle right here is 30 degrees. And then that, along with X, is a linear pair. They make a line together. So then we could do 180, because they add up to 180, minus 30, and you get, whoops, and you get that 150, either way. So that's just two slightly different ways to find that x is 150, using what we've learned about angles so far. All right, we're going to do a little bit on the back, page 201 here. Let's take a look at these two triangles at the top. It says, you demonstrated on the previous page that the sum of the measures of the angles in any triangle is 180 degrees. Now let's consider these two triangles. Angle A is congruent to angle D, so I'm going to label those with one little arc. Angle B is congruent to angle E, so I'm going to do this with two little arcs to show that those are equal to each other. Complete the reasoning to show that the third pair of angle must also be congruent. So now we're going to that last thing that we learned yesterday, that if two angles are congruent in one shape, then they're congruent, the third ones, or to the angles in the other shape, then the third angles are congruent. So it says in number 7, how do you know that C is equal to 180 minus A minus B, and F is equal to 180 minus D minus E? And the reasoning for that is simply because all three angles in a triangle sum to 180 degrees. So you can subtract the two you know to get the third one. The missing angle. All right. So number 8, remember that A and D are equal and B and E are equal. We have that marked. Why can you say that C is equal to 180 minus D minus E? Now those aren't even in the same triangles, the C and the D and the E. But let me show you why. It's kind of like what we talked about on the other page. Since we know that they're equal, if we know that what we said earlier, C, the first thing we said was C, number 7, equals 180 minus A minus B. But if A and D are equal to each other, which it says right here in the front, then you could replace it. You could replace D in the place of A. If B and E are equal, you can put E in the place of B, because they're equal. They're the same thing, just they're replaceable. So that would mean that C is equal to 180 minus D minus E, which is what is said there in number 8. So it's called substitution. We're just substituting it. All right, number 9. Remember that F is equal to 180 minus D minus E. So why can we say that C equals F? Well, the reason is it's kind of like substitution again. Because originally we said that F is equal to 180 minus D minus E, but now we also said that C is equal to 180 minus D minus E. So they're equal to the same thing. I'm going to type this one. Since they, we'll say, since C and F are equal to the same thing, they are equal to each other. It's kind of like saying if it's kind of like saying if person A has $100, person B has $100, then person A and B have the same amount of money. All right, finally, would this reasoning still be true if the triangles were right triangles or isosceles triangles? And the reason I want to explain there is yes, and it's because it doesn't matter. We know that these are true for every triangle. These relationships are true for any triangles. Because all triangles have angles that sum to 180 degrees. All right. I would like you to try this last one on your own. It says try another way. Draw a similar triangle. Use a scale factor. This is a little bit of a challenge one. Um, Try it because this will also bring back what we did with dilations in the past in a previous unit, and how if you have a scale factor, all you have to do is multiply by that scale factor. You can multiply the coordinates by it. You can multiply the side lengths by it to figure that out. If you have a protractor, you can check the angles, but one thing that should happen is that the angles should still be congruent. It's just the sides become half the size. That's what we're going to leave off for today for lesson 22.2. Again, we were learning to use about really going in depth about these different properties of angles and triangles.